Hello everyone, this is Aditya and we are back with another tutorial in the vRealize automation series. This time, we intend to make you understand the concepts related to tenancy and endpoints in vRealize automation. Let's dwell upon the concepts of tenancy, but before that, we just want you to remember what a tenant is. A tenant is an organizational unit in a vRealize automation deployment. It can represent a business unit in an enterprise or a company that subscribes to cloud services from a service provider. Now, each tenant has its own dedicated configuration, although some system level configuration is shared across tenants. As mentioned in our roles and responsibilities tutorial, the system admin is the one that can create new tenants. During the installation of VRA, a default tenant is created with the built-in system administrator account to log into the vRealize automation portal. The system admin can configure the default tenant and create other tenants. In the default tenant, the system admin can manage system-wide configurations such as branding and notifications, as well as it can monitor system logs. Generally, creating a single tenant is sufficient, but there can be scenarios where having a single tenant is simply not enough in trying to achieve what is desired. That is why we can have multiple tenants. And the concept of multi-tenancy comes into picture. Now, each of these tenants can have some exclusive services associated with them, which will be visible only to that tenant. They're called tenanted services and will be visible and consumable by that tenant only. On the other hand, the non-tenanted services are visible and consumable by all tenants. As you can see, all the services or elements, should I say, that are above the red line are tenanted, and all that are below the red line are non-tenanted. So the services or the components above the red line will be visible only to the tenant in which they were created. But the services or components below the red line will be visible to all the tenants. Now, if a particular tenant wants exclusive access to the non-tenanted services, it is going to require its very own vRealize automation instance. While we are talking about tenants, let us discuss the way to access them as well. To access the default tenant, go to https:// vRealize automation appliance fqdn/vcac. Whereas to access any other tenant, go to https:// vRealize automation appliance fqdn/vcac/org/ the tenant name that you are trying to access. The tenant name or the URL for the default tenant cannot be changed, but you can assign a tenant admin as well as an IS admin at any point of time. So up until now, we have learned that we can have single or multiple tenants in an environment. Depending upon the scenarios, we might want to think about the tenant design. We have three choices for tenant design. The first one is the single tenant architecture. Your second type of design would be multi-tenant architecture with infrastructure configuration done in default tenant. And the third one will be the multi-tenant architecture with infrastructure configuration done in each tenant. Let us now discuss each of these tenant designs. First up, we have the single tenant architecture. In this, all the configuration will take place in the default tenant. All the users will log into the vRealize automation portal through the same URL, but the view of the portal will be different for each user based on the roles assigned to their accounts. The single tenant architecture is the easiest one to set up, and it's especially suitable for small and medium-sized organizations. In a single tenant scenario, it is common for the system administrator and the tenant administrator roles to be assigned to the same person. But two distinct accounts exist. The system administrator account will always be administrator@vsphere.local, and you can create a different account, a different local user, and assign it the tenant administrator role. The next way to have a tenant design is a multi-tenant architecture with infrastructure configuration done in default tenant. This design is well suited for medium and big enterprises, where all infrastructure is centrally managed by IS administrator and fabric administrator in the default tenant. The shared infrastructure resources are assigned to the users in each tenant by using reservations. However, the tenants is somewhat autonomous in the sense that they are the ones responsible for user account management. Each tenant can have its own identity source, as well as can keep track of its catalog items and blueprints, etc. This diagram shows a multi-tenant deployment with centrally managed infrastructure. The IES administrator in the default tenant configures all infrastructure resources that are available for all tenants. The IES administrator can organize the infrastructure into fabric groups according to type and intended purpose. The fabric administrator for each group can allocate the resources from their fabric groups. Although the fabric administrator exists only in the default tenant, they can assign resources to business groups in any tenant. The other way to set up a multi-tenant architecture is to allow the tenants to set up their own infrastructure configuration. In the default tenant, only the endpoints and the system configuration will be taken care of. This design is useful for very large organizations, as all the configuration items have to be set for each tenant individually. There is obviously going to be a high administrative overhead. We can see a multi-tenant deployment where each tenant manages their own infrastructure. The system administrator is the only user who logs into the default tenant to manage system-wide configuration and creates tenants. Each tenant has an IAS admin who can create fabric groups and assign fabric administrator to them according to their respective tenants. Although fabric administrators can create reservations for business groups in any tenant, in this example, they typically create and manage reservations in their own tenants. If the same identity store is configured in multiple tenants, the same users can be designated as IS administrators or fabric administrators in each tenant. Now, that was sufficient information to make you understand the design implementations of tenants. As you can see in the name of this video, endpoints also need to be discussed. So let's show endpoints some love. So endpoints, huh? They're anything that vRealize automation uses to complete provisioning tasks. We create and configure the endpoints that allow vRealize automation to communicate with our infrastructure. Endpoints creation requires administrator level credentials and an appropriately configured DEM. Endpoint definitions are characterized based on certain types. Have the cloud endpoint. The cloud category contains the vCloud Air, vCloud Director, Amazon EC2, and OpenStack endpoint types. The second one we have is the IPAM category, that is your IP access management. This category is only visible if you have registered a third-party IPAM endpoint, such as Infoblox IPAM in vRealize Orchestrator workflow. Then we have the management category. This category contains the vRealize Operations Manager endpoint only. Then there is network and security. This category contains the proxy and NSX endpoint types. A proxy endpoint can be associated to an Amazon vCloud Air or vCloud Director endpoint. An NSX endpoint can be associated to a vSphere endpoint. Then we have the orchestration endpoint. This category contains the vRealize orchestrator endpoint only. Next up is the storage endpoint. This will have the NetApp ONTAP endpoint. Then we have the virtual category, which contains the vSphere, Hyper-V, that is your SCVMM, and KVM, RHEV endpoints. Connecting vRealize automation to multiple vCenter server instances requires an endpoint for each instance as well as an agent associated with each of them. You can configure additional endpoint types in vRealize Orchestrator and use them with supported endpoint types in vRealize Automation. You can also import and export endpoints programmatically. A little note for you over here. It is recommended to create the endpoint first before performing the agent installation, as you will know the name of the endpoint this way, and the agent installation prompts for the name of the endpoint. After an endpoint has been created and properly configured in vRealize Automation, there begins a data collection process to identify the compute resources available from that endpoint. Now, this can either be done using a DEM or a proxy agent. For example, for a vSphere endpoint, we can perform data collection of three types: the inventory, the state, and the performance data collection. The inventory data collection updates the record of the virtual machine whose resource use is tied to a specific compute resource, including detailed information about the network, the storage, and the virtual machines. This record also keeps information about the unmanaged virtual machines, which are the machines which weren't provisioned from the vRealize automation. It runs in every 24 hours by default. The default timeout period for inventory data collection is 2 hours. The next data collection type is the state data collection. It keeps a record of the power state of machines discovered through the inventory data collection. It also keeps record of the missing machines that vRealize automation manages but can't be detected on the endpoint. It runs every 15 minutes and the default timeout is 1 hour. The third type of data collection is the performance data collection. It updates the record of the average CPU, storage, memory, and network usage for each virtual machine discovered through inventory data collection. Now, this one runs every 24 hours and the default timeout is 24 hours. So, my fellow VMware professionals, this brings us to a close for this tutorial. We will probably see you in the next one. Bye bye.